This is section 11.7, the chain rule. And after you've practiced derivatives for a little bit, this section will make a little bit more sense. So make sure that you've covered sections 11.3, 4, 5, and 6 before tackling section 11.7. The chain rule has to deal with composite functions, or the composition of two functions. The composition of functions means when you plug one function into the other one. So h of x is g of f of x. So here's an example of how composite functions are used. I'm not talking about derivatives yet. Let f of x equal 2x minus 1 and g of x be the square root of 3x plus 5. Find g of f of 4. The way I would write this is g of something. F of 4 means I'm going to plug 4 into the function f. So I'm going to take 2, take out the x, see where I get this from, and I'm going to plug 4 into this function. So I'm plugging 4 into the function f. So here's a diagram. I'm plugging 4 into this box called f. Let's see what pops out. 7 pops out. If I plug 4 into the function f, out comes 7. I'm immediately going to turn around and plug that 7 into the function g. Let's see what happens. I'm going to need a little room here. So that's the square root of 3 times 7 plus 5. Square root of 26. So our function h, the big function, takes 4 and spits out square root of 26. Okay, but it does it through two functions. Let's try this. F of g of 4. Now these look very similar, so the question is, are they the same? Let's find out. Now let's plug 4 into the function g. So the function g is the square root of 3x plus 5. So I'm going to take out the x and replace it with 4. Let's simplify. I get the square root of 17. I'm going to take that, now I plug that into the function f, which was given up here. So this is going to be 2 times the square root of 17 minus 1. Unfortunately, there's nothing else we can do to that. That's just the 2 square root of 17 minus 1, an irrational number. So notice that these are not the same. What we can conclude is that, in general, f of g of x does not equal g of f of x. Okay? So it matters which one you plug into first. This last problem, they just want us to find, not plugging in a number, but just find g of f of x. So let's take g, and let's plug in f, which is 2x minus 1. What do you do with g? G means the square root of 3 times whatever plus 5. Take that whatever and plug it in. Now, we want to simplify this a little bit. This is the square root of 6x minus 3 plus 5, or the square root of 6x plus 2. And that's it. What about f of g of x? Is f of g of x the same thing? Let's see. This is 2 times something minus 1. The something is g of x. G of x is the square root of 3x plus 5. And really, there's nothing we can do to simplify that. Nothing gets in or out of the radical. Nothing gets simplified. So those are not the same thing. Please notice that g of f of x and f of g of x are not really even closely related. They're not the same thing. Okay? The chain rule says let y equal a composite function, f of g of x. Then, what do? Well, then the derivative is simple. You take the derivative of the outside, leave the inside alone, then multiply by the derivative of the inside. So this is derivative of the outside times the derivative of the inside. Another way to write it is you could write this as dy du times du dx. We'll use this to prove a few things later on. This is when you write y as a function of u is a function of x. U is the intermediate function in between the two. Don't worry about this. As long as you can do this, you're okay. So let's look at some examples. Find the derivatives of this. This is a function within a function. This is the inside. This is the outside. So to take the derivative, you take the derivative of the outside. Now, what I find helpful is cover up the inside. Do you agree it's something squared? Now, we know the power rule, right? The power rule says 2 times something to the first power. This is the power rule. But you leave the inside alone. Times the derivative of the inside. Ignore the outside. Look at the inside. What's the derivative of 3? It's 0 plus derivative of 5x is just 5. Now in this case, we can simplify. In fact, you can keep simplifying if you wish for this problem. That's not always the case. Okay. Let's look at this next problem. This next problem is complicated. This next problem has a lot going on. This next problem is a product. This is first, this is last, but the last is itself a chain rule. So this is going to take a while to do. The product rule says the first times derivative of the last, but the derivative of the last is a chain rule. So the chain rule, first times derivative of the last plus the last times derivative of the first. I'm going to leave the simplifying to you only because I'm running out of room quickly on this. It looks much more complicated than it is. You multiply all your constants together and it simplifies rather quickly. Let's do one more. This one has a quotient rule. So this is y equals 3x plus 5 to the 7th power divided by x minus 1. This is a quotient rule. So the derivative here is the bottom times derivative of the top, but the derivative of the top is itself a chain rule. Minus the top times derivative of the bottom all over the bottom squared. Let's go ahead and simplify this one. This one takes a little bit of doing. So I'm going to simplify the left side a little bit. Multiply 3 by 7, we get 21. 3x plus 5 to the 6th power minus 3x plus 5 to the 7th power times 1, doesn't really matter, divided by x minus 1 squared. Don't fall into a trap of trying to cancel things out. Remember, subtraction, you can't cancel anything at this point. Now there's a trick, something you need to know about this problem right here. Look at the common factors. Do you see how these two things are the same? 3x plus 5. So what we can do is factor. So I can take out 3x plus 5. I can take out however many they have in common. Well, this one has 6. This one has 7. So I can take out 6 of them. That's how many they have in common. I'm left with 21 times x minus 1 minus one more 3x plus 5. And before I do anything else, go back and check and see if you see what I did. Do you agree that if I multiply this in here, I get this? And if I distribute and multiply this by this one, I'm going to have 7 of them. Okay? So all I'm doing is factoring. I'm pulling out and then simplifying what's left over. So now I'm going to simplify in here, and let's see what happens. Maybe some good things happen. I don't know. 21x minus 21 minus 3x minus 5. Watch your signs. X minus 1 squared. Y dx is, let's simplify, adding like terms together. This is what, 18x minus 26 you can take out what they have in common. They have a 2 in common, but I believe that's all. So if I took out 2, I have 9x minus 13, right? There's nothing else in common. Unfortunately, sometimes things cancel out at this stage. Since everything's multiplied on top, if we had common factors, we could cancel it out, but we do not. So we won't. So a little bit of algebra to go along with this. Practice, practice, practice. Practice is everything for calculus.